page, we're going to work a little bit more with transformations. So the first thing we're asked is to describe the transformations. Well, we can do these easy ones first. Plus 1, to the left 1, up 5. And then what does this 2 do? Is it affecting our entire function or just the x value? And if you're unsure, sometimes I write it inside parentheses 2. If I put the 2 in there, now it's directly affecting our x, so it's the entire value. So it's our y values times 2, which means it's a vertical stretch with a scale factor of 2. Now this next one, we're asked to find the coordinate here. We're given g of x, and this point is translated to point P on a graph G. So it's a lot of words here, but we're asked to find this coordinate under the transformation. Well, what happened? Minus 1 moves it to the right 1, and half, just like this one, it's half of our y value. So if we have the coordinate 3, 2, to the right 1, it's going to be 4. Half our y value is 1. And how about this next one? What happens on this one? Well, this is really similar to the one above. Minus 1 to the right 1. 2, it's outside, so it's a vertical with a scale factor of 2. Now these next ones down, we have to decide if they're odd, even, or neither. So we can look at this first one here, and we could graph it. We'll bring up that calculator, or we can prove it without. If you remember, f of x equals f of negative x means it's even. F of negative x, f of the opposite, the opposite of f of x is odd. And looking at this one, I'm guessing it's even because of those exponents. So let's just check this even one. F of x, f of negative x. So we have 4x to the 4th plus 2x squared minus 5. We plug in negative x, 4 times negative x to the 4th plus 2 times negative x squared minus 5. Well, those even exponents, so our negative, it's the same as 4x to the 4th plus 2x squared minus 5. So it is the same, so it is even. And then it asks for end behavior. Well, if you remember our end behavior, we look at our highest power. And if you're not sure, we could always go to this calculator and we can graph it. And what do we have? 4x to the 4th plus 2x squared minus 5. And it ends like that parabola there. So our end behavior, that's where we fill in the blanks. As x goes to infinity, what does y go to? As x goes to negative infinity, what does y go to? Well, they're both going up, so they both go to positive infinity. This next one, it looks odd, and we can graph this as well. So what do we have? Negative 5x to the 5th minus 3x. And was it plus 7 or minus 7? Plus 7. Well, it's definitely not even, and it doesn't look odd either, because even is symmetric to the y-axis. Odd, you can rotate it, but it has odd exponents. So let's double check that odd. F of negative x equals the opposite of f of x. So negative 5 times negative x to the 5th plus, minus 3 times negative x plus 7. Does that equal the opposite of f of x? So opposite of that entire function. Well, the negative stays, so this becomes positive 5x to the 5th plus 3x plus 7. Distribute here, 5x to the 5th plus 3x minus 7. So close, but they're not the same. so it's going to be neither. And then that end behavior, as x goes to infinity, as x goes to negative infinity, what does our y go to? Well, again, we know it's odd, so it's going to end this way because of that negative. So as x goes to infinity, y goes to negative infinity. As x goes negative infinity backwards, y is going up to positive infinity. And the last thing we have to do on this page is find the slope. Well, this one's easy. Negative 1/2. We can solve this one for y. So let's see, 6y equals 14 plus 3x. Divide by 6. So our slope is 3/6, which is 1/2. So they're close to being parallel, but they're opposite sides, so they are neither. Remember, parallel is the same, perpendicular is that opposite reciprocal, like 3/2 would go to negative 2/3.